are they going to join the class, or maybe start our discussion? Hello.
Yes, sir.
I can find only 21 students in my class at this time. Are the other going to join, or your
Yes, sir.
classmates
They will
are going?
join.
Okay. Let the other two join. Before that, we will start discussing the very basic things related to our microprocessor and microcontroller subject. So in the today's class, I will get you familiar with what the stuffs that we are going to discuss throughout the whole semester in form of your course curriculum, that is microcontroller and microprocessor. Okay, so we will be going through the course curriculum that is being defined by GTU in this subject, that is microprocessor and microcontroller. Okay, so before getting into the stuff, I would like to know from your side that what actually you are expecting that you are going to study in this subject. Any idea? First of all, we'll have some discussion related to this, and then I will let you go through the topics that we are going to discuss. What are the units there are? What are the things that you are going to study in the semester for the subject? Okay. So, what is your expectation by taking on the subject microcontroller and microprocessor? What you are going to get? Let me talk individually. Let me talk to 27 number. Is there 27 number in my class?
Yes, sir.
Yes, 27 number. Can you get a spotlight over the things that you are going to study in this subject? Have you gone through the course curriculum of it?
That's a little bit.
A little bit, at least. Just clarify that thing. What little bit means?
એટલે સર ખાલી આમ જોયો છે કોર્સ એમ સર.
Course. I think in the first lecture I have instructed all of you to just download your curriculum and need to go through this thing. So have everyone gone through that?
Yes,
Yes,
sir.
sir.
Okay, so first of all, let me know that what are the things that you have gone through. Let me talk to 45 number. Yeah, 45 number.
Yes, sir.
Yes, what are the things that you have gone through this subject? Means
Sir,
looking at the course curriculum.
sir, we are going to learn about all about um, history of microprocessor and microcontrollers, then their architecture, their applications, then
Mm.
about um, some sort of languages, then
Okay.
programming.
Okay, so you are supposed to study the architecture of your microcontroller and microprocessor, and you will also be uh, get familiar with how you can program your microprocessor and microcontroller in this subject. Okay, so before going into the detail of the course curriculum, the first thing that we need to understand is what is microprocessor. So are you having any idea related what a microprocessor is? Let me talk to number 54. What is microprocessor?
Yes, sir.
54 number, yes. Yes, tell me, what is actually microprocessor? Have you heard about this microprocessor
Yes, sir.
previously anywhere? Yeah, yeah.
Sir, I think it is a type of small or a miniature circuit in which we can perform logic, arithmetic.
Yeah, of course you are definitely right. But have you seen microprocessor around you?
No, sir.
You haven't seen microprocessor around you? You did not find microprocessor anywhere?
Like, sir, I've seen in, well, not physically, I have touched or seen.
Okay, but where you can find this microprocessor? In which gadget
Sir, in
or
mobile phone?
where?
Sir,
Yes,
laptops.
yes, you can find microprocessor in your mobile phone. Yes, then yeah, definitely you can find microprocessor in your laptop. Okay, yeah. So I think all of you would be using laptops. Yes. So let me take an example of a laptop to give an example of what a microprocessor is. Okay. Are everyone having a laptop with them, or maybe probably they may be having a desktop? Yes or no?
Yes, sir.
Yeah.
Yes,
Yes,
sir.
sir.
We are
Yes.
having.
Okay.
Yes, sir.
So yeah, so everyone probably would be having a laptop with them, and you would definitely find it out somewhere. There is a sticker that it would be written as Intel Core i3 kind of thing. Okay, I'm having i3. You may be
Yes,
having
sir.
an higher version than. So which version you are having?
Core i5, 8th
I5.
I
generation.
i5 8th generation. Very nice. Anyone else?
i5 10th generation.
i5 10th generation. Oh, બહુ જૂનું છે
i7
તમારું તો.
11th generation, sir.
એનો મતલબ મારું તો બહુ
Sir,
જૂનું
i3.
છે યાર. i3, yes, yes. I'm having a
I7 11 generation, sir.
Yes, sir.
54 number. Yeah, we both are having i3, so we are a little bit older than the other one. Okay, so yeah,
Yes, sir.
so this Intel i3, i5, i7, i9, whatever you are telling, 10th generation and all that thing, actually this is what your microprocessor is. Okay, this is your what you are talking about, i3, i5, maybe this is your microprocessor. Okay, so this is a processor which is in your laptop. So we are going to study this processor. Okay, yes or no? So I think now you know that what a processor is. Processor is nothing, but it will get the data, it will process according to what the instructions you have given, and then finally it will give that process data back to you. So that is what the simple task of a microprocessor. Okay, now at this stage it is very difficult for us to understand what is i3, i5, or a high level, high end. If I want to study the architecture of this i3 microprocessor, then it is quite very difficult because it is having 3 core, 7 core, 9 cores. Okay, so we cannot do that thing, but he has to get a little bit idea of how the microprocessor is being formed, what would be the architecture of a microprocessor, how actually the basic processing is being carried out in a microprocessor. We will take a very basic microprocessor, which is an 8-bit microprocessor, which is developed by Intel, and it is 8085. Okay, so this is the 8085 microprocessor that we are going to talk about in form of a microprocessor in our subject. Okay, so with the help of this basic microprocessor, we will be able to study that how a microprocessor is organized, how actually the instructions are being executed, how the data is being processed, how the memory is being connected to our microprocessor and all that thing. So that particular stuff we would be discussing in form of a microprocessor. Okay, yeah, your my mobile phone is also having a processor, but it would definitely, I think it is an ARM series processor that are available. It is not provided by Intel, but it is an ARM core processors which are available in your generally in every microphone, in your mobile phone. So that is why. So whenever you are discussing about RAM and the internal storage or a ROM, means if you are talking about this type of stuff in any kind of a device, you can see that yeah, there would be a microprocessor present within it, which would be having a processing capability. Okay, so this that is what we called it as a microprocessor. Now let's talk about the another term, which is what we called it as a microcontroller. Okay, so have you heard about microcontroller previously in any semester or anywhere else? Let me talk to 47 number. 47 number.
Yes, sir.
Yes, 47 number. Can you tell me anything about microcontroller? What you have heard about this? Have you heard this word microcontroller anywhere?
I heard it, but I never seen it physically.
Yeah, you would have not seen it physically, but can you tell me any place where you can find this microcontroller?
With in CPU, with CPU.
CPU, that is what we called it as a microprocessor. Okay,
Nee,
generally this is,
I have to say with CPU, not in CPU.
huh?
Means with CPU.
With CPU, I'm not able to understand what you want to tell. Okay, a very simple example means you can tell me anything where you can think about having a microcontroller inside.
Uh,
So this is a free question to everyone. Anyone who is having answer to this
Arduino.
question, yes, who 27 number, yes. Let me go to 27 number.
Arduino board.
Yeah.
Arduino Uno board. Yes, I think Arduino Uno board is nowadays very popular amongst the student community. Yes, yes,
Yes.
Arduino Uno board or Arduino Mini, Arduino Mega, whatever. Arduino boards are nowadays very popular amongst the student community for having a small project development kind of thing. Okay, so yes, definitely you can find a microcontroller in this Arduino Uno board. Okay, I think whenever you purchase a Arduino Uno board, there would be a black chip with having 40 pins. Okay, and there would be written something as at mega 3 to p at mega, yeah, at mega 32 p, that would be written in on it. So that is what we are having a microcontroller. Okay, so microcontrollers are nothing but they are the standalone system. Okay, so there is basic difference between a microprocessor and a microcontroller. Means microprocessor is having a processing capability, but it is not having the other peripherals being implemented onto the same chip. Means you are having a memory, but it would be external to the your chip. Okay, processor chip. Okay, there are peripherals, all that, and all these things will require an interface, means 8255, 8259 kind of interface ICs would be required by your processor to get the things interface with. Means if I want to interface a 7 segment LED with my microprocessor, then 8259 is a chip which is required for interfacing my LCD with my microprocessor. Okay, but in case of microcontroller this is not the case. Okay, everything are on chip. Okay, means if you talk about RAM, yes, RAM is on chip. ROM, it is also on chip. It will be having an IO devices, timers, counters, all the serial interface peripherals, they are all available on the microcontroller. So microcontroller is on, in all a whole package available in form of all the devices which are available onto the chip. Okay, you can think about many places where you can find. I think you would have seen your uh, temperature, your air conditioners. Okay, it is the best example of a microcontroller. You will find it out that you set the 26 degree in your system, and yes, that system will continuously maintain at 26 degree in the room. Okay, that can only be done with help of a microcontroller. Means there would be a sensor which would be sensing the temperature. It would be giving that data to a microcontroller would be comparing the data with the set value. If the set value is smaller or a bigger, according to that it would be initiating a signal that can be given to an actuator, and then actuator will start the plant, and yes, the plant will keep on running until the time where you get your desired value. So this is a very simple way you can implement any system with the help of a microcontroller. There are n number of widgets that you can find it out around you where you are having microcontrollers within embedded within it. Okay, so this is a very fundamental subject that you are going to study in this semester, which will open a gateway to a very good branch of your electronics and communication, which we called it as an embedded system. So this is a very fundamental subject that you need to carry on, you need to study in form of microprocessor and microcontrollers, which each are the very basic fundamental blocks of your embedded systems. Am I clear? Am I clear?
Yes.
Yes.
Yes,
Okay,
sir.
so
Yes, sir.
let us see that what are the things that you are going to. Okay, yeah, one very important thing that I want to tell you, so that you maybe it will help you to create an interest in the subject is, I think all of you are fond of Arduino Uno board because they are very handy, they are easily available in the market, and the project can be easily developed onto the on this particular board. So in this particular subject, we are going to study a microcontroller which is available in your Arduino Uno board. Okay, so in Arduino Uno, we are having an Atmega 32 microcontroller. So this is a microcontroller from an Avr family. Okay, so we are going to study an Avr family microcontroller that will help you to understand your Arduino Uno properly, as well as it will help you to program your Arduino Uno, and it will also help you to use all the features which are available in your Uno board. Okay, so I am sharing my screen with you, in which I would like to show you that what are the content of this particular subject. Is my screen visible to everyone?
Yes, sir.
Yes,
Okay.
sir.
Okay. So this microprocessor and microcontrollers, they are very important for any embedded system. So if you talk about an embedded system, you cannot talk of an embedded system without a microprocessor or microcontroller. Okay. So this is your 3141008 subject, which is microprocessor and microcontroller, and the pre-required course for this particular subject is digital system design. I think you already, all of you would have studied digital electronics subject in your previous semester. So this is a prerequisite subject. Have you studied or not digital electronics?
Yes, sir.
In
Yes, sir.
that you would
Yes,
have
sir.
in that you would have studied that how conversions and finite machine cycles and multiplex or decoder, all that thing you would have studied in it. Okay, so
Yes.
that is a prerequisite course for this particular subject. Okay, now the teaching schemes includes 4 lectures, 2 practicals, and it is in all a 5 credit subject, in which it is supposed to have 70 marks of end semester examination, 30 marks of your progressive assessment, 30 mark which is an end semester evaluation, and 20 marks which is an internal progressive assessment. Okay, so if I want to tell you that this is a 70 marks, that is your paper that you are going to give. Okay, so this is the 30 marks which we used to have it in form of a mid semester examination. Okay, end semester exam evaluation, which is a viva, that would be of 30 mark, and your internal means term work submissions, attendance, and all that thing would be included by of 20 marks. So in all you are having 150 marks of subject, which is having 5 credits. Okay, now let's get into the detail of what the things that you are going to study and what are the weightage of that particular topic in the subject. So the first unit is all about your microprocessor. Okay, so in this microprocessor, we would be talking about history of microprocessor and microcontroller. Okay, history means how it is. It has got evaluated. What was the first microprocessor developed? What was the first microcontroller developed, and all that thing. And the most important thing that we will be going to discuss in this unit is the difference between microprocessor and microcontroller. Okay, both are having a same family, but they are the different members. Okay, microprocessor is in all a different stuff, and a microcontroller is in all a different stuff. Even though both of them, they are having a processing capability. Okay, which will help you to add the intelligence to the system. Means if you want your system to work independently, if you want your system to have a little bit of intelligence, then you need to go for this to anyone out of these two to be get embedded in your system. Then and then only your system will become smarter. Okay, but we need to have a wise decision between whether we need to go for a microprocessor or a microcontroller. So that can only be done if we are having a very clear cut difference between what is microprocessor and what is microcontroller. So that we are going to discuss. I have given you an idea that microprocessor is nothing but it is having a processing capability. Yes, it is a multitasking. This is a single tasking kind of thing. It is all the memories and all that things are external to this microprocessor, but in microcontroller it is available internally. All the supporting peripherals, they are available in microcontroller, but we need to have an interfacing ICs for the microprocessor. So that is the major point of difference between a microprocessor and microcontroller. Then we will see some of the applications of the microcontroller. Means your AC, your remote, your mobile phone, your gadgets, all they are having a microcontroller. the bail system of our college. So there are a number of places where microcontrollers are being used. So we will be looking into some of the applications of a microcontroller. Then comes an important part, that architecture of an 8085 microprocessor. So as I have told you that if I want to study microprocessor, then I cannot go for directly a complex structure, or I cannot go for i3 or i5 Pentium or any another processor. Okay, so I need to take a very basic processor and I need to study the architecture of it. So we would be taking a very basic microprocessor, which is an 8-bit Intel microprocessor 8085. So we will be looking into the architecture of this 8-bit microprocessor. So let me take a pause at this point of time and let me explain you what is 8-bit microprocessor. Okay, so this microprocessor and microcontroller, they are having a capability to process the data. So what length of data the processor or a controller process at a same point of time, that is what we call it as a bit capability of a microprocessor. Okay, so generally we are having 8085, which is an 8-bit microprocessor. The Avr microcontrollers that we are going to discuss, it is also an 8-bit microcontrollers. Okay, but nowadays we are having 32 64 bits microprocessors and microcontrollers which are available in the market. So at the same time, it can process an 8-bit of data, or it can process 16-bit of data. That defines that what is the bit capability of your processor. Okay, so we'll be discussing a microprocessor and microcontroller which are both of 8-bit. 8085 is also an 8-bit processor, and AVR, that is also an 8-bit microcontroller. Okay, we will be looking into the in detail functional operation of 8085. Then we would very quickly go through the memory and IO interfacing. We know that the role of microcontroller in an embedded system. Okay, we will also discuss that it is having a fundamental role to be played. Microcontrollers, they are playing a very fundamental role in development of any embedded system. So AVR is not only the microcontroller which is used. There are a number of other microcontrollers, MSP. There are so many other controllers that can also be used, 805, and there are so many. But yeah, nowadays AVR is the most popular microcontroller. That is why it has been included in your subjects, and we are going to discuss that microcontroller. Okay. So this first unit will be up to this. It would be discussing about the microprocessor, and then after this onwards whole, your subject is going to discuss about your microcontroller. Okay. So that is all about your unit number 1. Now in unit number 2, we are going to see the architecture and the instruction set of an AVR microcontroller. Okay, AVR is nothing, it is an advanced virtual RISC. Okay, so while discussing about this AVR basic and all that thing, we will also be discussing about what is RISC and what is CISC and all that thing. We will also be discussing about an Harvard architecture and von Neumann architecture. So okay, I know that it would be a little bit difficult for you to digest this thing at current time. I'm talking about risk, I'm talking about CISC, but yes, as and when time comes, I just my intentions to tell you this is you just need to remember that there is something what called as a risk. There is something what called as an CISC, hardware architecture, von Neumann architecture. So at a time when I'll be discussing, yeah, you will get able to get recapitulate, means recall that yes, sir had discussed about references in the introductory lecture. Okay, so we would be talking about AVR microcontroller and its architecture. It registers. Okay, so now registers are nothing but they are the okay. I think all of you have studied register in your digital electronic subject. So can anyone tell me what do you mean by a register? Let me talk to 22 number. Hello, 22 number. Hello, 22 number. 22 number, are you there?
Yes, sir.
Yes, 22 number. Can you tell me what do you mean by a register? Okay, anyone else who know what is register?
It stores the data.
कौन बोलियो?
19.
19 number. Yeah, register is a place where you can store the data. Okay, so now whenever we talk about processing of a data, then we required a temporary storage of the data. Okay, so we would be talking about the registers. So these registers are available in your microprocessor or a microcontroller. Okay, in their CPU, in their whole hard code, the places would be there where you can temporarily store that data, because yeah, we know that whenever we want to process the data, temporarily this data must be stored somewhere. So you would be having a registers. So you will come to know that this AVR is having 32 registers. Okay, 32 registers are there in AVR where a temporary data can be stored. Then we will be talking about the status register. So status register is nothing, it is a register where you would be available with the status of the CPU. Okay, so when the processing is being carried out, then we need to know that what is the status of the CPU. Means, let's say that a very simple example I want to tell you that, let's say I'm having a two numbers. Okay, if I want to add two number, if carry is generated, means after adding the number, whether the carry is generated or not, I need to know, because that would be used for the next operation. Okay, so that information can be available from the status register. Means, let's say I have subtracted a minus b and whether it has resulted into 0 or not. Okay, so I need to know the status. So that status can be seen from the status register. Okay, now we will also be looking into the memory space. Okay, so already we know that if we talk about any processing unit, whether it is a microprocessor or controller, it requires a memory. Okay, so generally we have two type of memory. One we called it as a permanent memory, another we called it as a temporary memory. Okay, so which memory is permanent memory? Do you know that? Hello, which memory we called it as a permanent memory, and which memory we called it as a temporary memory? Yes, 19 number.
So permanent is ROM and temporary is RAM.
Yes, so temporary memory is RAM and permanent memory is ROM. So if we want to store a data, we generally store data in RAM, because we don't want permanent data. Means data, let's say that I want to store the temperature. Okay, current temperature. So I do not have to store it continuously. So that type of thing I would be storing in RAM. But let's say I want to store the program. Okay, so the program would be stored into ROM. Okay, that is a permanent memory. With that, we are also having an another memory which we called it as an EEPROM. Okay, so basically, if we talk about a microcontroller, we need to see three things, three memories: that what is available RAM, what is available ROM, and what is available EEPROM. EEPROM is just to store some lookup tables, serial numbers, and all that thing. And ROM, we also called it as a flash memory. Okay, why it is called as a flash, I'll be discussing as and when the time comes. But yes, flash memory. So the amount of flash, yes, it will be helpful to know that what length of code that you can write into that particular microcontroller. Okay, so we will be looking into the memory space and how that memory is organized. That is also we need to see. Suppose if I want to store the program, then from which location I need to start program storing the program, all that thing that can be seen with the help of memory space. Okay, so Avr microcontroller. So Atmega 32 is an Avr family member. So we, and it is very well popular known. So we would be studying Atmega 32. Okay, Atmega 32 means it is having a 32 kilobyte of flash memory. Okay, 32 kilobyte. So that we would be discussing. Okay, we will be looking into the pin configuration and function of each pin. Pin configuration, it is having a 40 pins. Okay, out of this 32 pins, they are used for IO purpose, means general purpose input output. And this IOs, they are divided into four sections, A, B, C, D, and each section is having an 8 bit. So in all, 8 2s are 32, 8 4s are 32, 32 pins are there for IO, and the other pins, they are just for VCC, ground, A reference and crystal connections, and some are not connected. So we will be looking into all the functions of the 40 pins of your AVR microcontroller. Then we would be looking into the address mode and instruction set. Okay, address mode is whether you are directly addressing it or whether you are indirectly addressing it. So that you would be looking into the addressing mode, that okay, addressing memory space. Yes, in memory there would be locations, and each locations is having an address. So how you are pointing out this location, that is what we call as an addressing mode. Okay, we will be looking into the basic instructions of your AVR microcontroller. Means if I'll say that there is a microcontroller, I need to write a program, and looking into the program, the microcontroller will get the instructions, and according to that it will perform the task. Okay, so the instruction set, it is very important to be known. If you know the instruction set properly, or if you know the instruction set, then and then only you will be able to program the microcontroller. Excuse me. So these instructions, they are divided into different categories. One are data transfer instruction, means the instructions that are used to transfer data from one register to another register, or to get the data from IO to, or send the data to the IO. Then arithmetic instruction, there are logic instructions, compare instruction, rotate instructions, shift, branch, call. So these are the different type of instructions. Means these are the categories of instructions. Means data transfer instruction, arithmetic and logic instructions, rotate and shift instruction, branching instruction. Branching instruction means many of time what we need to do is that if particular condition is satisfied, we want to skip a particular scratch of the program. So all that thing can be done with help of a branching instructions. Bit manipulation instruction. Okay, now many of time what happens that we cannot process a bit of a data. Means as we talk about that it is an 8-bit microcontroller or 8-bit microprocessor, we need to process 8 bits simultaneously. Okay, but many of time it is not required. We just need to know the bit values for 1 bit out of the whole data. Okay, let me know that whether you know bit or not. What do you mean by a bit? Bit, B-I-T, bit. Hello.
Sir, it consists of 8 byte.
8 byte? No. 8 bits form a 1 byte.
Yeah, yeah, sir. Yeah, yeah.
Huh. Bit is nothing but it
Sir,
is a
zero
zero,
and one.
zero one, that already you have studied in your digital electronics. It is what we call it as a bit. Okay, so if I am having a 1 byte of a data, 1 byte, it is nothing a collection of 8 bits. Okay, and out of this 8 bits, if I want to change or if I want to look at upon only 1 bit, then also the instructions are there. So this feature is only available in your AVR microcontroller. Okay, that it is a bit processing capability. Means single bit can also be processed or programmed. Okay, so this would be your unit number 2, and unit number 3 we will be talking about the assembly language and C language programming of your AVR microcontroller. Okay, just have just hang on for a minute. I'll come back to you. Just hang on for a minute. Hello. Hello, am I audible to everyone?
Yes, sir.
Okay. Now, as already we have seen that a microprocessor and a microcontrollers, they are having the capability of processing a data. And this data would be processed according to what the instructions we are going to give. So the set of instruction we called it as a program. Okay. So now what I need to do is, suppose if I want any task to be carried out by you, then I need to instruct you in a language which you understand. Okay. So these are the languages which a microprocessor or microcontroller can understand. So there are actually basically three way we can give an instruction to a microprocessor or microcontroller. One, we called it as a machine level language. Okay, machine level. So we need to go up to the level of machine. Okay, and I think all of you would have heard about this thing, that a microprocessor or microcontroller can only understand a language of 1 and 0. Yes or no? Have you heard about it?
Yes,
54
sir.
number?
Yes.
Okay.
Yeah.
So yeah, you would have heard about that. Yes, machine understands only ones and zeros. So if you write your program in form of ones and zeros, a stream of ones and zero, then that language we call it as a machine level language. Okay. But do you think that it would be possible for us to write the program in form of 1010 kind of thing?
No, sir.
No. No, it won't be possible because it would be very difficult for us to interpret. Means if I have written a string of 1 0, and then yeah, anyone cannot understand. Okay, so that's why for make the process little bit easy, we go for an assembly language programming. Okay, so in assembly language programming, what we used to do is we used to generate an opcodes. Let's say a very simple opcode is move instruction, mov, or we can easily understand mov, it is nothing but it is move, and we would be having a corresponding opcode for this instruction in form of 1 and zeros. Okay, so that is what we call it as an assembly language program. Okay, so you can write the program in assembly language, means you can write the instruction step by step. Okay, and then you will be providing that to a tool which we called it as an assembler. Okay, so the assembler will convert your assembly language programming into the machine level programming. Okay, machine level programming. So there is also one way of doing it, and the other way of doing it is a C programming, means a higher level programming. Okay, so in which what we can do is we can write the program the way we used to write the C code. Okay, programming in C, or maybe in Java, or maybe in Oracle, or any other higher level programming language, and we will give that program to a tool which we called it as a compiler. So compiler will compile a program for us, and it will generate a machine low code which can be easily downloaded into your machine or microprocessor. So whether you are writing your code in assembly or a C, generally you need to have a hex file, hex file. So whether it is an assembler or whether it is a compiler, it will finally generate a hex file, and that hex file can be loaded into your microcontroller or microprocessor. So we would be looking into that assembly and C language programming of your Avr microcontroller, because Avr supports both assembly as well as C. And finally we will be uh, trying to download the program into your microcontroller. So this unit number 3, it will all be dealing with your programming, that how you can do the programming either with assembly language or a C language. But what we are going to do in the class is we will try to combine this two, means unit number 3 and unit number 4, means as and when we would be discussing about the instruction set, with the same time we will also be discussing about the assembly language programming, means we would be looking into the instructions, and we will arrange all the instructions in the sequence to form a program, and we will be looking into the assembly and the C level programming with unit number 3. Okay, then in unit number 4, we will be looking into the on chip peripheral. Chip, yeah, I think all of you know what is chip. It is nothing but it is an IC. Okay, So we are having all the things on chip which is not available in, so whatever the things you can look at over here, it is the point of difference between the microprocessor and microcontroller. Okay, in microprocessor you do not have IO ports. I already talked about that there are 4 IO ports. Okay, A, B, C and D, and each port is of 8 bits. Okay, so we will be looking upon this 4 IO ports. We will also be looking about a timer. So timer is a very important part of a microcontroller. Any microcontroller, whatever the microcontroller you will feel or find, it will be having a timers in it. So timers they would be using as timer and counters both. Then we will also be looking upon what the interrupts are and how these interrupts are handled by your microprocessor, microcontroller. Now, dictionary meaning of interrupt is nothing but it is just to break the flow. Okay, means if let's say the microprocessor is or microcontroller is doing some particular task and some event occur outside the microcontroller which must be handled very immediately, then it would be formed or it must be given in form of an interrupt. Okay, so we will be talking about interrupts. It is having a serial ports, so all the serial communication, that is SPI, I2C, UART, okay, TWI, all serial communication protocols are supported by SPI serial peripheral interface. Okay, I2C is a form of a serial communication. Okay, do you know what is serial communication and parallel communication? Can you tell me what is the point of difference between what is difference between serial communication and parallel communication? And one example. Hello, do you know what is a serial communication and what is parallel communication? Yes, 19 number. I am having lot many expectation from you.
Well, in
Serial.
serial communication, the data is transferred in series, and in parallel communication, the data is transformed in parallel. Means we
8 bit
can
at
take a data at a beat, at an instant in parallel communication.
Okay. So parallel communication is the faster way of communication. Serial is the slower way of communication, but the number of interconnection line is creating a problem. So if parallel communication, suppose if I want to have an 8-bit parallel communication data, I need to have a channel, which is an 8-bit channel. Okay, or 8 channel, 8 wire connections are there. But in case of serial communication, you can do the communication with only help of 2 wires. Okay, so yeah, so you are SPI, I2C, they are the most common serial communications which are available. Okay, then so all the communication protocols they are being supported. How we can use, how we can communicate. So communication is very important when you talk about any embedded system. Means one chip must be communicating with the other one, or one system must be communicating with the other system. So this system communication we carried out over the serial communication with the help of SPI, I2C, TWI or UART. Okay, universal synchronous or synchronous transmitter receiver. That is the most UART is the most commonly used serial communication protocol. Okay, then finally in unit number 5 you would be looking into how you can interface your LCD, your keypad, your TFT. Okay, all this thing you can easily interface with your Avr microcontroller. Okay, with that there is ADC and DAC. Okay, so ADC means analog to digital conversion and DAC means digital to analog conversion. So we know that all the sensors would be generally giving you data in form of an analog signal, and if I want to process this information I need to convert it into digital form. So how you can interface your ADCs and DACs with your microcontroller? So generally we are having ADCs, means 8 channel ADC is already available in your AVR microcontroller. So you can use that thing to connect a sensors to it. Okay, now for an output generally we used to have relay or an opto isolator. Generally we use relays for turning on and off. You would have seen that applications, that if temperature increases 35-degree fan must turn on, kind of an application. So that the relay, how you can have operate relay with your microcontroller. So there is a chip which is required to operate a relay. that we will be looking. Opto isolator generally we use to separate the control circuit with the power circuits. Okay, stepper motors. We know that stepper motors nowadays they are stepper and servo. They are generally very important nowadays. Okay, so how we can interface the stepper and servo motor, that we will be looking. DC motors will also be seen that. So these are the three general motors we choose to connect to a microcontroller, means stepper, servo or DC. I think all of you would have seen that whenever you purchase a kit of your Arduino Uno, with that it is also being available with stepper motor, DC motor and servo motors. So you can use that thing. It can be easily interfaced with it. Okay. It will also be shown you that how a display can be interfaced over SPI or I2C protocol. Okay, and finally, we would be concluding our subject with discussion of an RTC interface. RTC is nothing but it is a real-time clock. That how RTC real-time clocks can be interfaced with the with your AVR web, and yeah, we can also program it in either assembly or so. So these are the stuffs that we are going to discuss in this subject throughout the whole semester. So if you are having any kind of query, you can ask me. If you are having any kind of query up till the things that I have discussed, you can ask me. Hello. Hello, are we connected? Am I audible to everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so any question?
No, sir, not till now.
Okay, so in the next class, we will start upon discussing with the very basic things related to our microprocessor. We will try to divide the subject in two parts. The first half we will be talking about microprocessor, and in the second half we will be talking. I cannot say that it is second half, but it can be 3/4 of the portion. We will be talking about a microcontrollers. Okay. So thank you. Have a nice day.
Thank you, sir.
Thank
Thank
you,
you,
Thank you,
sir.
sir.
sir.